networking type of applications and data transfer on your Qantas. Today, we are going to talk about another wireless personal area networking standard, which is called ZigBee. ZigBee is basically targeted for applications which require low data rate, and basically it is meant for Internet of Things. It is more inclined towards wireless sensor networks. So whatever yesterday we had some doubts regarding FSHSS and DSSSS from one institute, and that other things also may emerge today. So we will discuss those things at the end of the lecture. So the outline of my talk is today basically will include an introduction to ZigBee. What is ZigBee? An overview of 802.15.4 wireless personal area networking standard for MAC and PHY layer, the architecture of ZigBee, its implementation, and possible applications. So what is ZigBee? I hope you all have heard about ZigBee. ZigBee is an established set of specifications for low rate, specifically low rate wireless personal area networks. It is a technological standard which has been created for control and sensor networks. It is based on IEEE 802.15.4 standard and has been ratified till now. There are other such standards also which are based on 802.15.4, but this one which is being developed by ZigBee Alliance. It is a non-profit organization. It is a collaboration of many companies who work together to come up with a standard. The ZigBee Alliance extends the upper layers of the stack which are not defined by 802.15.4. So as I described over the Bluetooth SIG yesterday, similarly a brief overview of ZigBee Alliance is that it is organized as an independent, neutral, non-profit corporation in 2002 for WSN standards development. It is an open and global network. Anyone can join and participate in the activities of the ZigBee Alliance. There are over 400 companies worldwide which are members as on date. The membership is global, that means it spans right from Europe to Americas to the Asia and the entire part of the globe. The activities of the ZigBee Alliance include, number one, to develop open standards for wireless sensor and control, then product certification and compliance programs, as well as the branding, market development, and user education. The ZigBee trademark is basically held by the ZigBee Alliance. So I would like to say that ZigBee is a key enabler of the IoT. IoT is Internet of Things. Till now the major stress was on Internet of data and all those things, but with the development of the technology, Internet of Things is started to become a reality. And home automation, hospital automation, those type of applications are finding more and more focus of the companies, and they are coming up with innovative products in this field. So what do I mean by Internet of Things? You can see the various typical application scenarios of a Internet of Things. In the home, for instance, you can have interconnected lighting sensors, lighting management system. You can have temperature control, automated temperature control, metering platforms, and then through some hybrid technology like LOWPAN, you can integrate those all systems with your mobile phone, and then onto the m-commerce. Again, digital smart city type of applications wherein you can have advanced metering platforms, You can have automated CCTVs and all those things in the near reality. These are some of the members of the ZigBee Alliance who are working together to come up with this particular standard. They ratify, their members on board, and they ratify the various standards which are propagated by ZigBee Alliance for compliance. Now, first of all, how the name ZigBee came. Basically, at the heart of ZigBee is mesh network. So, the name ZigBee has came in for erratic zigzagging pattern of bees between flowers. The way bee wanders around flowers is represented by the name ZigBee. It symbolizes the communication between nodes in a mesh network. And as you all know, in a bee hub, there are three levels of bees. One is a queen bee, then there are drone bees, and then there are worker bees. So similarly, the architecture of ZigBee has network components which are analogous to the queen bee, which we call a coordinator. Then we have drones, which we call routers, and then we have worker bees, which we call end nodes. In the ZigBee parlance, and there is some different terminology as far as 802.15.4 is concerned. That we will come up later. As I already told you, that the usage case scenarios of ZigBee are basically sort of automation in the home, in the hotels, in the hospitals, all those type of applications which you can think. Industrial and commercial applications include AC controls, pressure control, monitoring, all those type of applications. Then we have consumer electronics. Today, in a single room, we have a lot of gadgets which are remote controlled. And we have a different remote for our TV, for our DTH, for our AC, for DVD player, and so on. But with a ZigBee radio enabled remote, you can control at the time around 66,000 devices. So it's a huge potential. With a single remote, you can control all those devices, and line of sight is also not an issue. As far as IR remotes are concerned, you need to have line of sight for sending and receiving signals. But with this mesh networking support, you need to have line of sight. Then toys and games. Today, toys are not just, they are very highly sophisticated toys are coming in. So instead of a radio control, you can have ZigBee control toys. PC and peripherals. In this field, ZigBee is not very prevalent right now. We are more looking Bluetooth in this parlance, but ZigBee is coming up with solutions for integration of personal computers and peripherals also. Because it has the capability of integrating a much larger number of devices than the Bluetooth. In a Bluetooth Piconet, yesterday as we talked, there can be maximum 8 devices at a time. Then personal health care. This particular application in India right now is not very prevalent, but globally, where like countries like Japan, where elderly population is more, the number of people living in houses alone are more, then they have systems like personal health monitors, motion sensors, which monitor the motion of a elderly in the house. And the moment if they do not detect something, some change for greater than a quanta of time, they send emergency signals to the local police stations or local medical hospitals, and that way they help the people out there. Then home building automation is a very prominent area of ZigBee. ZigBee can control everything from pressure, temperature gauges to your sprinkler system, to your microwave, to your even keyless entry to your house can be enabled. As we see in the advertisements nowadays, in Godrej there are some products which are coming in. They are not ZigBee based, but they are in that domain. So just everything which you can imagine for a wireless sensor network or in general short range communications is available with ZigBee. I detailed you the open systems interconnection model yesterday in great detail, and also talked about the protocols and interfaces, which I think would be clear to you now. Today again, I will talk about the protocol stack of the ZigBee, and it is also more or less modeled around the OSI model. It is not strictly following that model, but it is modeled around that model. And here also, as you can see, the lower MAC and physical layer. ZigBee has three operating frequencies depending on the geographies. This 2.4 gigahertz band is the industrial, scientific, and medical band, which is available free of cost globally. Then you have this 915 megahertz band, which is available in US only. In India, as you all know, our GSM operates in the 900 megahertz band, and it is a very precious frequency range in our country. But in US, mostly the telecom is on 1800 megahertz band, and this 915 megahertz band is available for ISM applications in US. Then in Europe, there is one channel in 868 megahertz. So the basic radio of ZigBee is optimized for these frequency bands. However, in India, if it is applied, only this particular frequency is available. Recently, China has opened some other frequencies also for this ISM band, and ZigBee Alliance has come up with standards for those radio ranges also. Then you know the MAC layer. These two basic layers have been defined by IEEE Working Group 802.15.4. Above it, the network layer, the security mechanism, and the application programming interfaces. These parts are developed, defined, standardized, and ensured for compliance by the ZigBee Alliance. And at the top is the application space, where the end vendors or customers develop their own applications for their specific need, or they can use the predetermined or pre-configured applications through public profiles, as we talked about Bluetooth yesterday. So this is the basic stack of the ZigBee, and here is where 802.15.4 plays a role, and this is where ZigBee Alliance plays it. Now, we will have a basic overview of 802.15.4, its motivation, the channels in which it works, and then we will come back to the ZigBee. So, IEEE 802.15.4 working group basically targeted applications, which I discussed in my previous transparencies. They targeted applications such as home networking, automated networks, industrial networks, interactive toys, and remote metering type of applications, wherein the power metering is done through remote station without manually going to each and every household for getting the power inputs. So, what were the design drivers? What were the basic design drivers? The design driver was, first of all, you would have thousands of sensors in a small space. So, cabling would not be feasible. So, what you need? You need a wireless solution. Secondly, the sensors are frequently standalone. So, their power requirement should be low. For example, if your TV remote, you need to change your battery cells every half an hour or every day, then it will be a great first. It is of no use. It is only useful or seems to be useful when you have to change those AAA batteries or AA batteries once in a year. Similarly, if thousands of sensors, the batteries are to be changed frequently, then that technology won't survive for long. So the basic design driver was to have very power hungry, less power hungry devices. So low power was one of the design drivers. And then the sensors are frequently isolated. Sensors can be in isolation. So a moderate range, not very much, but a moderate range was thought of, and these were the basic challenges which were faced by the standards committee. And on the basis, taking into consideration these challenges, the committee came up with a standard whose general characteristics are as below. We have three data rates. Data rates are 250 kbps, This data rate is achievable in the frequency band of 2.4 gigahertz. Then 40 kbps is available in the Americas in the 915 megahertz range, and 20 kbps is available in 868 megahertz band. These two frequencies are not available if India is concerned because they are paid frequencies in our country. Then star or peer-to-peer operation. However, ZigBee is basically mesh. Support for low latency devices. By low latency devices, I mean they can wake up very fast. Fully handshake protocol for transfer reliability. Handshaking is there. By handshaking, I means first of all, a connection is established and then the reliable transfer takes place. Low power consumption. One of the basic requirement, and three frequency bands of operation as I detailed you above. 16, there are 16 channels in the 2.4 gigahertz ISM band, 10 channels in the 915 megahertz ISM band, which is available in USA, and one channel in 868 megahertz band, which is available in Europe. Some new frequencies will also come in, which are available in China, and right now the standard or radio for that is in the development. Now, as we have discussed yesterday, the PHY layer is basically further subdivided into two radios. One is meant for this 868 and 915 megahertz band, and the other is made for the 2400 megahertz band. It is the actual hardware, the packet generation, reception, data transparency for those devices, and the power management functions are performed at the physical level. These are the various channels which are available. Channel 0 is at the 868.3 megahertz. Then there are 10 channels in the 902 to 928 megahertz spectrum with a band gap of around 2 megahertz. And then we have 16 channels in the 2.4 gigahertz to 2.4835 gigahertz band with a band gap of 5 megahertz. This is a basic overview of the physical layer of 802.15.4. Every PHY packet has a physical service data unit. This is nothing but what is coming from the MAC layer. This is the MAC payload actually. It can be of 0 to 127 octets. Then a physical header is appended, a packet delimiter, and a preamble. This basically constitutes around 6 octets. Then there is 802.15.4 MAC layer. This is basically the data link layer which manages the link of the hardware and sits above the physical layer. The tasks which are associated is channel acquisition, retention management. ZigBee follows CSMA CB. Then frame security and error correction to an extent to ensure the reliability of the data. Again, the design drivers, as I have discussed in the first slide, were extremely low cost, ease of implementation, reliability, short range operation, and low power consumption. So it is a simple but a flexible protocol. So this is basically the MAC payload, which has a MAC service data unit, which it is received from the network layer, and then it appends a header and footer, and this entire thing becomes the MAC protocol data unit. The MAC frames can be of 4 types. It can be a data frame, which contains the actual data which is to be transferred to another node. It can be a beacon frame. Beacon frame is basically, I will detail about in the later part of my talk. It is for the case when both the coordinator and the node go to sleep, and they wake up at a time which is decided a priori. A beacon is sent, coordinator wakes up, and a beacon is sent to the all the nodes to as a indicator to wake up and be ready for the data transfer. Then the acknowledgement frame mechanism is there to ensure reliability, and there is a command frame for the MAC commands which is to be sent over the air to the other devices. This is a typical frame structure, and the maximum size would be around 127 bytes for the MAC payload, as I have told earlier. So first of all, why was ZigBee needed? A question which is obviously comes in mind. Basically, we have lot of wireless standards across data rates. In the range of around 10 Mbps, we have the standard 802.11, and which we commercially know as Wi-Fi. So this is basically used for LAN type of applications, local wireless LAN type of applications. Then we have BiMAX, which is basically in the domain of wireless metropolitan area networks. That broadband, what we nowadays know as broadband with a dongle. So naturally, this has an extended range, and the airwaves in which it operates are paid airwaves. So, and then you have Bluetooth, which works in the data range of zero point 0.1 to 1 Mbps, and further it has the data rate has been enhanced in the range of 2 to 3 megahertz Mbps also, as we discussed yesterday. But there was a gap in this range. Low data rate applications, 0.01 Mbps to 0.1 Mbps. There was no such standard, and this is how ZigBee was thought of. ZigBee uniquely fills a gap for low data rate applications, which require a very low data rate and low latency times. Now, what does ZigBee do? ZigBee is basically designed for wireless controls and sensor networks. As I already told you, Internet of Things. It operates in the personal area network and device-to-device network, and it provides the connectivity between small packet devices, control signals, this type of applications. Control of lights, switches, thermostats, appliances. Think today there is a direct physical connectivity between the fan and the switch. So a wire is there, the power connection is there, but think a switch having a ZigBee radio as well as the fan having a ZigBee radio. So there is no need to have the power full power connection at the switch end. You just have to have a Bluetooth radio enabled switch which will have two batteries which will work for a year. Definitely it will make life on things very simple. The architecture of ZigBee. The basic network characteristics of ZigBee are that you can have 65,536 client nodes. This is around 64 bits. We have 27 channels over 3 bands. Typical data rate in the 2.4 gigahertz band is 250 kbps. ZigBee is optimized for time critical applications and power management. So naturally the design drivers are low latency and low power consumption. It provides full networking support. As you can see in the figure, a typical ZigBee setup is shown where this is the network coordinator. These are the full function nodes. However, as far as 802.15.4 is concerned, a full function node is a router as well as a coordinator. And the end nodes are reduced function nodes. So what is a ZigBee coordinator? It is basically the central figure in a ZigBee network. In any type of topology, either tree or mesh or star, there should be at least one ZigBee coordinator. It is only one in the network. It initiates the network. Whenever the network is initiated, a channel is selected, and a PAN ID is assigned. Network address is assigned, which usually coordinator takes say address 0x0000, and then it stores information about the network. All devices can communicate with the ZigBee coordinator either directly or through the routers. It provides or establishes the routing functionality. Routing functionality can again be direct or indirect. In case when you have more empowered routers, you can have indirect routing functionality where binding tables are maintained at the router level, or you can have indirect routing where the binding tables are maintained at the coordinator level. So naturally, if you have if you want if you have more enabled devices in your network, then the power consumption will be somewhat more. So it's an optimization. What do you want from your system? And it also acts as a bridge to other networks. There are some protocols, 6LOWPAN. There is one protocol which integrates your ZigBee coordinator with the IP, Internet Protocol. So thereby you can have ZigBee enabled mobile chips and you can control your coordinator from your mobile phone directly. Then there are other type of devices which are relatively less empowered than the ZigBee coordinator. They are called ZigBee router. In the 802.15.4 parlance, these are also called full function devices. 802.15.4 defines only two types of devices, full function and reduced function. Whereas ZigBee has defined three types of devices. So ZigBee router is an optional component. In case of a star topology, you don't need a router because the coordinator is at the center and it can communicate directly with all the nodes in the network. However, in case of a tree topology or a mesh topology, routers are required. It routes between the nodes. Now the routing strategy depends on the topology which is being followed. In a tree, as you are aware, that only a parent can communicate with the child. So the communication takes place in that manner. In mesh, two routers at the same level can communicate directly. So routing decisions are more optimal as far as power consumptions and other things are concerned. But naturally, the system requirements are more. Routers basically extends the network coverage because they are relatively high power devices and they can have childs, and they manages the local allocation, address allocation and deallocation. Since a router can have childs, so the local addresses or short addresses are assigned by the router to its children. Then we have the ZigBee end devices. These are basically at the lead part of the topology. Usually the sensors houses at the nodes, but they are cheapest of all data device types, and naturally they have low power capabilities. And they are more in number in any network. Optimized for low power consumption, cheapest device type. They can communicate only with the coordinator, and the sensors are deployed at the node. Now the second thing is what type of traffic we can have in a ZigBee network. So basically three traffic types are permitted. One is that the data can be periodic, some sort of applications which require, for example, a temperature monitoring system. So your system is defined after every half an hour the temperature is temperature sensed by the sensor is transferred to the coordinator. So the rate is fixed that every half an hour it will wake up, it will send a signal to the coordinator and the coordinator will receive. Another traffic type is data is intermittent, where application or a stimulus dictates the rate. For example, smoke sensors. Whenever a smoke is detected, it will send the signal intermittently. Until and unless no signal is detected, it won't send anything to the controller. And then the data is repetitive, where it is fixed that the data will come in after every sufficient time. So there is one GTS mechanism out here in the ZigBee communication, which ensures that a particular node gets a guaranteed time slot for communicating, because ZigBee works on the concept of CSMA-CB, carrier sense multiple access collision avoidance, CSM. So when the data rate is fixed at a priori, then in this case a guaranteed time slot mechanism is implemented. Now these are the traffic modes. One typical traffic mode is the beacon mode. This is the case when basically your coordinator is also battery powered. Usually this type of mechanism is followed when your coordinator is also power hungry. Here both a beacon is sent periodically by the coordinator, which is basically a wake-up call for all the network devices. In this case, synchronization is very important, because when the beacon is sent, at that time all the other end nodes should also have waked up to receive that particular beacon. Otherwise, there will be issues. There is some time lag before the actual data is sent, so that the timing offset can be adjusted, and then the actual data is transmitted by the network device to the coordinator. You can also have an optional acknowledgement mechanism. So here, as I told you, that the coordinator can also be backup powered. It can also be battery powered. Both the coordinator and end device can go to sleep once the data transmission has taken place. Naturally, the total energy consumption of the system would be lowest. But as I told you, that synchronization or timing is very necessary. If when the beacon is sent by the coordinator, some node doesn't wake up or is not synchronized to wake up at that particular time, then the signal will be lost. Now, this is a typical communication scenario. A network beacon comes in, then there is a cool off period or an offset period, which we call. Then these are the various contention periods. Here, any node can access the channel for sending data by using CSMA CA. What is CSMA CA? Carrier sense for multiple access collision avoidance. In this scheme, whenever a node has some data to send, it senses the carrier, and if the carrier is free, it sends the data over the channel. Otherwise, it waits for a random period again and then senses the carrier again for free. If it is not free, it again waits for a time when it is free. It avoids collision in this manner. Then there are, at the end, there are some guaranteed time slots. These guaranteed time slots are meant for those nodes which have a fixed priority data to be sent over the channel. So during this period, whoever has been allocated these slots, guaranteed time slots, they communicate with the coordinator. And finally, there is a beacon ending signal, and after this, all the coordinator as well as the nodes goes to sleep. Now another traffic mode is a non-beacon mode. In this type of mode, basically what is thought of is that the coordinator is sufficiently powered. It is not power hungry. It is backup powered or mains powered. So naturally the coordinator is always awake. The coordinator oblique routers have to stay awake. Robot power supply is needed in this case. It is a heterogeneous sort of network where some devices, that is the nodes, are power hungry, whereas some devices have sufficient power and it is not an issue for them. And asymmetric power is there. Whenever, since this is awake all the time, whenever the network device has some data to send, it senses the channel. If it finds it free, it communicates over that channel, and an optional acknowledgement can be received by the network if it is required. It depends on the criticality of the application. Now, the various topologies which are available with the ZigBee network, the foremost and the basis of which it is known is mesh topology. Now, here you can see a typical ZigBee network wherein this is the ZigBee coordinator. Now, the ZigBee coordinator has a child node. It is connected to 1, 2, 3, and 4 routers. These routers have their further children. Here you can see these are the child routers 1, 2, 3, and 4. Now, since this is a mesh, you can see two child routers at the same level can communicate between them. Another topology which ZigBee supports is tree topology. The only visible difference which you can clearly see is that two child routers cannot communicate between themselves. If they need to communicate, the path would be like this. And then a typical example or a good example of ZigBee mesh networking which I got somewhere is this. Suppose this switch is a ZigBee enabled radio switch and this lamp is also ZigBee enabled. This particular optimum routing has been defined or established for communication between the lamp and the light. Now suppose a particular node goes down. These two nodes have gone down. Now the route is disturbed. So in a mesh networking, alternative routes can be established and then the communication takes place through these alternative routes. How this mechanism, binding and all those things happens, we will come on. Now, up till now, this is the basic stack architecture as we have discussed in the initial frames also. We have the physical layer, physical radio, and the medium access layer defined by IEEE 802.15.4. Some of the actual hardware concepts I will discuss right now. Then we have the network layer, above it. The tasks which are performed by the network layer are network organization, route discovery, which was there in case of mesh when a route goes down or initially also. And then the message relaying feature for communicating the messages over the air. Then there is an application support layer. This application support layer basically acts as an interface between the actual applications and the network layer. It performs device binding and messaging. Then you have a ZDO. As you can see, that ZigBee device object. It spans from the application layer to the network layer. Basically, it is an application which is available with every ZigBee radio, and it has an endpoint address. Endpoint address is basically an identifier for an application. So ZDO is assigned an endpoint address of 0. And at the top is the applications. You can have up to 240 user applications at a time running on a single ZigBee node. They initiate and join network, manage the network, determine the device relationships, and send and receive messages. Now, how is the ZigBee network implemented? This is the physical layer of a ZigBee network, and it operates. I've given the case of 24 omega band specifications. You can see here the radio uses 4 bits per symbol. Initially, the binary data is converted into symbols, and then we have DSSS, direct spread spectrum with 32-bit chips. Yesterday, somebody asked that Bluetooth uses DSSS. No, it is not correct. Bluetooth uses FSHSS. DSSS is available with ZigBee as well as Wi-Fi. Now, the basic difference between DSSS and FSHSS is normally if I have to transmit a 0 and 1, the bandwidth which is taken by the symbols is very high. This leads to possibility of jamming and data corruption and all those. Now, what we do with DSSS is we convert these narrowband signals into a broadband signals. For example, here we are using 32-bit chips. Means I represent the 0 with for instance, if I am using a 6-bit chip, so I represent the 0 with 6 symbols. And similarly, this one with another code, for instance, 0101. And I communicate this signal to the other end. The receiver at the other end is also aware of the chip length and the symbol designation. So it decodes from this the actual signal. Now this spreading helps in converting a narrowband signal into a broadband signal, and thereby the data error possibilities and other things are reduced. Military, in case of commercial communication, usually chipping of 10 to 40 bits is used. Whereas in military communication, they use up to 10,000 bits of chipping. So for every single bit, they send 10,000 bits over the channel. Thereby, since both receiver and the sender knows this algorithm, they can decode the data, actual data from there. Now, what is FSHS? This is DSSS. I uniformly spread a narrowband signal into a broadband. in FSHSS, I have a frequency spectrum. As in case of Bluetooth, there were around 80 channels available in the spectrum of 2402 megahertz to 2478. Now, what I do is my signal will normally go by a signal channel. Okay. For example, I select the channel 1. Now, my receiver, which is connected to the transmitter, also is clocked to this particular frequency. So, when the signal comes over this channel 1, it receives it on the channel 1 at the other side. The signal is very narrow band. When I have a capability of 80 channels, I am using only 1. But this creates the possibility of jamming, interference, and all those other things. Now, to reduce these effects, what I do is, instead of sending the data over a single channel, I randomly use all the 80 channels. First, I send my data by channel 1, then randomly I send my data by channel 3, then randomly I send my data over channel 5, and in a random way I use all the pattern in which I will use these channels to send the signals over the air is known to my receiver. That pattern is known to my receiver. In what pattern I will send over which channel in the frequency. So automatically the receiver will adjust its radio settings randomly as per the known algorithm to whatever channel data is coming. So in this manner, the entire spectrum is used, thereby reducing the chances of jamming and interference and all those other things. You can have adaptive frequency hopping also, in which further mechanisms, this is a simple sentence. Now you can have further mechanisms, wherein your algorithm will randomly choose only the channels which are clean, which are silent, because in a single environment you can have Wi-Fi, you can have Zigbee, you can have Bluetooth. So interference is natural and normal. So for that, they will add other considerations also, like whether a channel is silent, it will search for, but that algorithm is handshake between both the sender and the receiver. And based on that algorithm, both can receive over the entire. So, symbol to chipping is done with 32-bit chips, and then we have QPSK modulation in case of 2400 megahertz band. You can a lot of technical literature is available on QPSK. You can easily read it. And then you have the sine half wave impulses. Similarly, for 868 and 1500 megahertz band, the radio has 1 bit per symbol scheme. There is differential encoding. Here the DSSS is done with 15-bit chips. We have BPSK modulation and RC impulses. These are some of the general specifications. Error vector magnitude is less than 35%. Power requirement is in the range of 500 microwatt. Now, these are basically the functions of a MAC layer. Beacon, only non-beacon, how the channel is to be accessed, what is the traffic mode, define the super frame structure which is to be sent in case of initialization of the network, and whether it is a slotted or a unslotted CSM. Another task which is performed by the MAC layer is management of the personal area network, channel scanning, PAN ID conflict detection and resolution, starting the personal area network, sending the beacons, device discovery at the lower level, device association and deassociation, and so on. Then transfer handling is also performed by the MAC layer. The transfer handling can be transaction based when the transmission is indirect, or it can be acknowledged or non-acknowledged, and then the guaranteed time slot management. What is GTS? I think it's clear to you now. Then frame security is also ensured. It provides security features like access control, data encryption, frame integrity by refreshing the frame, sequential frame freshness, and now with the MAC establishing the network, this is where the things we have come in. This is the coordinator node. It initially started and it selected a PAN ID, assigned itself the short address of 0x0000. Then new nodes have come in. They are connected to the coordinator 1, 2, 3, 4, and 5. They can be routers as well as end devices. Now, up till now, whatever is done is only up to the level of 1 hop distance from the coordinator. Now, suppose 5 is a router. So, since the router is also capable of having children, so it gets associated from the node 6 and 7. Now, if the coordinator wants to communicate with the node 6 or node 7, how this will be done? So here comes the issue of routing. And routing is not handled by the MAC layer. Routing is handled at the level of network. So this is the next level in the ZigBee stack, which we call the network layer. Now in this picture you can see above the network layer there is the application support sublayer. This application support sublayer acts as an interface between the actual applications and the network layer. The communication of the application support sublayer with the application objects takes place through SAPs, service access points, and ZigBee device object, which is assigned an endpoint address of 0, also communicates. However, the span of the ZigBee device objects is parallel to these levels also. Now, what are the tasks which are performed by the network layer? First of all, it performs the task of distributed address assignment. The address assignment can be a tree structure or be managed by the higher layers. Within the ZigBee networks, we have two types of addresses. One is the 64-bit MAC address, which is unique, and the other is the 16-bit network address, which is assigned by the coordinator, and two entirely different ZigBee networks can have same network addresses within that network. But the MAC address would be unique. Again, this 16-bit network space is divided among the child routers. Naturally, if we have 4 child routers, if we divide it, the entire 16-bit address coordinator will divide into among 4 routers. And then these child routers can further divide their space to their children. Now, the routing decision making, basically, the parameters which determine the routing decision making is we can have the maximum child count per parent. How much children a parent can have. Maximum child routers per parent. Number 1 was maximum child count per parent. Number 2 is maximum child routers per parent. and then you can also have a metric called maximum network depth. These all parameters decide your routing decisions. I will have a give you a good example. Suppose I have maximum child count 2. Okay. Maximum child routers also 2. And the network depth also I have decided as 2. And here is a typical network. The 0 is the coordinator. It has 2 child routers, 1 and 4. And 4 has 2 children, 6 and 5. Now, as per my policy stated above here, this 4 has 2 children, which is the maximum limit. Again, the depth has also reached to 1 and 2 levels. So, suppose a new node comes in and wants to join the router 4. So, is it possible? No. It will be naturally space is available with this router number 1. So, on the basis of this 2 will get associated with the child router 1. Another task which network layer performs is root cost estimation. Naturally, every system wants to send the traffic over an optimum network of an optimum length. So, the various metrics to compare the goodness of route are considered. One such is the link cost between the two neighbors. How much power or how much distance is required for the communication. On the basis of individual link cost, the total route cost is determined. However, this is only not the sole consideration. You have to take other factors also, like the power descriptor statement, what power descriptor is saying. If a node is expected to go down very early, although it may be on a shorter route, naturally it is not good decision to consider that particular node. Now another network layer task is route discovery. Basic algorithm which is followed out here is AODV, allow on-demand vector algorithm. It is modified to the ZigBee requirements somewhat, but the basic algorithm is that one. So you might have read that particular algorithm in that the things. This is how a route is discovered. Find or update a route between a specific source and destination. Route discovery is started if no active route is present in the routing table. Now this routing table can be maintained at the coordinator level. In that case, it is called indirect binding. It can be maintained at the router level. In that case, it is called direct binding. Now, a route request is broadcasted by the parent router of the end node which wants to discover the route. The routing table entry is generated for hops to source. The endpoint router, the parent router of the destination, it replies with a route response packet. This route response packet reaches the source router through various channels, and depending on the metrics which are associated with that route response packet, the best path is determined. A routing table entry is generated in the source device. This animation will make things more clear. Here, I have not shown the child routers, child end nodes of this router or this router. But suppose I want to, any child node of this router wants to find a route to any child node of this router or coordinate. It can also be a coordinate as well. So initially, a route request packet is generated by this router. Naturally, it is broadcasted through the entire network through different paths. It reaches the destination router or coordinator. Then a route reply packet is generated from the destination router. And naturally, it reaches there first by the optimal path. And this is how a route is generated, and the binding, the routing table is maintained either, as I told you, at the router level, or it can be at the port level. Usually, it is done at the router level. I think I have already discussed this. Routing, check if routing table entry exists. Initiate route discovery in the manner discussed on the light slide if it is not available. And hierarchical routing as a follow. Another task of network layer is route maintenance. As I shown you in that switch and bulb example, in case a particular route goes down, in case nodes on a particular route goes down, so orphaning procedure is to be initiated to remove those nodes from the routing table entries and to find the alternative routes in case of a mesh. Again, it can be situation that I have changed the batteries of that dying node. So again, I have to insert that node again into my network, and then again all the routing table entries will be accordingly rearranged. Orphaning and reassociation is the basic word which are called for. Now, above the network layer is the application support layer. This application support layer is basically an interface of the network layer with the application framework. The application support sublayer primarily performs the following tasks. It provides an interface to the network layer. It performs the task of data transmission as an interface. Binding. What do I mean by binding? Suppose I have a switch. This switch is capable of with a repeated. This switch has applications and is capable of sending these three types of commands: on, off, and down. Suppose there is another device, which is a bulb. Now, this bulb is capable of receiving on, off, and down. But when they are in isolation, communication can't take place. So, a binding needs to take place between the switch, application endpoint on the switch, and the application endpoint on the bulb. For this, binding needs to be a entry needs to be created in the binding table, and that binding task is performed by the application support. The basic as in C and other we have operands and variables. Here in ZigBee parlance, the atomic unit or atomic variable is called a cluster. Sorry, attribute. And a group of attributes forms a cluster. Every device is identified by a device descriptor. And every device descriptor can have up to 1 to 240 application endpoints, which are user defined. An application endpoint is nothing but an application which is running over a device. So this switch can concurrently control around 240 devices with different applications running on it. Now these, for any meaningful communication between these two, the application endpoint with a cluster referring to these things has to be binded with the application endpoint at the line end with both these receiving attributes. So this is how a binding table entry is created, which will have the source device descriptor plus application endpoint plus cluster ID with the destination device descriptor, destination application endpoint plus the receiving cluster ID. So whenever a on goes from here, it will, any cluster will receive on out here and it will switch on the bulb. This is how a binding table entry is created. And that binding table is maintained by the application. Now at the top your application endpoints. So you can clearly see that every application object has a endpoint address system. User applications can have 1 to 240 endpoints. Means at a time you can run up to 240 applications on a single ZigBee device. This ZigBee device object is assigned an endpoint address 0. This is the default which is not available for users. And finally, one address 255. That endpoint address 255 is assigned for broadcast. If you want something to be broadcasted to the entire ZigBee network, that message is generated from the application object 255. Now this is the basic framework of an application which specifies the data types by means of attributes and cluster. Attributes are basic units, group of attributes are clusters. Then there are device descriptors for each and every device. Thereby it defines or describes the frequency band in which it will operate, its power description, whether it is backup powered or it is battery powered, application flags, version, serial number, manufacturer, etc., etc. This is how it identifies itself. Then you have a very important application endpoint called ZigBee. Important role to play as far as a ZigBee network is concerned. Whenever a ZigBee network is initiated, who initiates a ZigBee network? I talked about end nodes, I talked about routers, I talked about a coordinator. So who initiates a ZigBee network? Initially, first of all, the coordinator comes alive. It is the coordinator which initiates a ZigBee network. It wakes up, it searches for a channel, it selects a particular channel which is clean, which is having less interference from Wi-Fi and Bluetooth and all those other things. Once that channel is selected, it assigns a PAN ID. It ensures that the PAN ID does not conflict with any other PAN which is available in that space. It assigns itself a short network address of 0000, and thereafter it assigns network addresses to the routers or its children's. All those tasks are performed by the ZigBee device also. It defines the role of devices within the network, number one. Then it initializes the application support layer, network layer, and the security specification. Offers services like device discovery, object service discovery, binding, and security management, and assembles information about the network for the coordinator or the router. That is the binding table. It can be direct or indirect. Now, this is something which is application aspect, basically certification aspect. What we call is ZigBee compliant platform. If a manufacturer comes up with a product for which the application profile has been developed solely by the vendor, however, it is ensured that the radio used is in accordance with 802.15.4 and the stack is positively compliant with the ZigBee stack, then such a product or such a platform is called ZigBee compliant platform. The platform certification, which is done by the ZigBee Alliance, ensures that all parts of the stack other than the application are compliant with the ZigBee standard. Allows network interoperability but does not imply interoperability at the application level. नेटवर्क तो इंटरऑपरेटेबल होगा बट ZigBee कंप्लाइंट प्रोडक्ट में ये जरूरी नहीं है कि आपकी एप्लीकेशंस आपस में इंटरऑपरेटेबल हो बिकॉज़ application profile is not certified by the ZigBee Alliance. But with a ZigBee, then what do I mean by application profiles? Here you can see I told you the cluster. These are the attributes of a particular cluster. Fan off, fan on, temp set, time set. Then there is another switch cluster, off, on, scene 1 and scene 2. For example, this switch is controlling lot of things. It is controlling lighting also. So you can program the scene 1 at the switch. Now this switch can control 10 lights and it is broad daylight time. It is also controlling the air conditioning. So if it is broad daylight, you can have a profile wherein you don't need much of the lights. But since sunlight is full, you need air conditioning. Whereas the scene 2 can be an evening scene, wherein light is required, air conditioning temperature or air conditioning is not that much required. So those scene-based programming can also be done for each individual switch. Application profile define what messages are sent over the air for a given application. Devices with the same application profiles interoperate end-to-end. Interoperability standardized हो जाता है यदि आप same application profile use करते हैं. तब मैंने बताया था आपको, but basically जो profile है वो आपने vertical slice through provide कर देती है through the entire stack. And if you go to the website of Zigbee Alliance or Bluetooth SIG, you will find lot of profiles. Those are basically made public by the Alliance so that you use those profiles as it is so that your product is integrated. Now this is the case of manufacturer specific profiles and the product will be called Zigbee compliant. And when a profile is also defined and given by the Zigbee Alliance, then the product is called a Zigbee logo product. इस तरह का जो प्रोडक्ट होगा जो एप्लीकेशन प्रोफाइल भी Zigbee की यूज की होगी जिसमें it will be called a Zigbee logo product. This some pictorial views of the various applications in which Zigbee can be used. उनमें बेसिकली अभी ब्लूटूथ आता है बट उसके साथ इशू क्या है कि मैक्सिमम 8 डिवाइसेस एट ए टाइम एक्टिव हो सकते हैं इसमें 64 बिट मैक एड्रेस है इतना न्यूमरस डिवाइस इतना पॉपुलर अभी नहीं है वैसे बट वी हैव डिवाइसेस आ गई हैं ट्रेन सिस्टम्स करके एक अमेरिकन कंपनी है उसने इंडिया में Zigbee बेस्ड एयर कंडीशनर्स वाटर स्प्रिंकलर्स डोर कंट्रोल सिस्टम्स को बेचने शुरू कर दिए बैंगलोर की ब्लूटूथ बेसिकली ब्लूटूथ सोचा गया था एडॉक टाइप ऑफ एप्लीकेशंस के लिए फाइल ट्रांसफर करनी है आपने इस तरह की जबकि ये थॉट ऑफ ही किया गया है फॉर कंट्रोल टाइप ऑफ एप्लीकेशन बेसिकली जब आप एसी की बात करते हैं तो उसको ऑन ऑफ टेम्परेचर कंट्रोल सिग्नल्स है बहुत डेटा इन्वॉल्व नहीं है पूरी फाइल नहीं भेजनी है मुझे कुछ एट्रीब्यूट ही पास ऑन करने हैं कि ऑन कर दो ऑफ कर दो इन ए क्लस्टर तो इस टाइप की एप्लीकेशंस के लिए ही ये सोचा बट इट डजंट इमेजिन दैट Bluetooth has established itself and of late Bluetooth has come in with a Bluetooth low energy protocol वो इसी एप्लीकेशन स्पेस को टारगेट कर Now you can see in a typical home you can have entertainment control system lighting control इस तरह से similarly in the factory you have AC control environmental monitoring pressure gauges all those things can be connected to the coordinator and with a common program you can manage everything. Home awareness systems, these are commercially available home awareness systems. Everything is interconnected. Range extenders for metering type of applications, then you have shut-off valves, sensors, power sensor, attention sensors, reminders, all those. In-home patient monitoring. This has not become very popular because healthcare condition in our country is very poor. So these things are a distant dream right now. Commercial lighting control. This also because at times we see that street lights are not done manually. So as far as the daylight timings changes, that is not very much adapted. At times you see when there is a cushion period between the longer days and smaller days, lot of times you see street lights burning even at the. So with this, you can have a wireless control. Now again, maintenance is very easy because if there is some problem with the switch, you not need to interfere with the 420 volt power. Because the switch is independent of the power supply. It does not need main switch. Maintenance is very easy. Similarly, this is basically in hotels, it is done with that key currently. That can also be done with it. Metering platform. I will show you. Again, it can also act as a gateway. The coordinator can get connected to a Zigbee enabled chip which basically houses the 6LoWPAN protocol, which provides an interface between the IP and Zigbee. There is one city, Gothenburg in Scandinavia. It is a Zigbee smart city. The entire water metering, power metering is done remotely using Zigbee. So there are around, it's a city of 5 lakh citizens, there are around 2 lakh 60,000 meters, of which 42,000 are indoor, and there are 1 lakh 80,000 in metering rooms. There is also rural area, so that it is entirely connected with the, you can go to the net and see a lot of details about this. And this is how Zigbee wishes to change your life. A Zigbee enabled keyless entry. Once you enter, since the coordinator can have various profiles in it, so it can adjust everything as per your preference or requirement for a particular time that you can set. So meet and greet, sensible sensor, climate control, safer space, no hazard lighting, and smart sprinklers. Basically, what we call a smart house. So this is all. Uh, okay. So any queries from the associated centers? I think the FSHS doubt would be cleared, and similarly DSSS I have also detailed sufficiently. Are there any queries from the centers?
Hello, sir.
Anji,
Sir, my query is what is the need of synchronization?
what is the need of synchronization? In
Synchronization
which case?
in any
Uh,
district? Yes, sir.
when in case of beacon mode, synchronization is required basically because if the timings are not matched, then there can be case of data loss. For example, if the node coordinator which is also battery powered and the end node which is also battery powered, naturally they are not synchronized, then in that case the backup timings of both of them will mismatch, and there are chances that your communication is lost.
Okay, sir. Sir, when we transfer digital data, finally through medium, it goes in analog form or digital form.
It is modulated. Basically, both type of modulations are available, and it depends how what is required actually.
For example, such as QPSK modulation is being used.
Yeah.
Then through medium, it will go in analog form or digital form.
Yes, naturally, analog only.
Okay.
Hello.
And
Sir, in case of Zigbee architecture,
yes.
what is physical radio?
What is
Physical radio.
physical radio? It is a Zigbee radio which operates at 2.4 gigahertz.
Okay. Sir, from the previous lecture of Bluetooth, we have a
Yes.
term that is frequency hopping.
Yes.
What is that?
I discussed it. I will repeat it once again. example of just two channels. Okay. Now, I have some information which I can send through any of these two channels, either channel 1 or channel 2. So, in the normal case, if I select a particular channel 1, so naturally my transmitter will send it over the air, and at the receiver, since the receiver knows that the transmitter is going to send the signal over the channel 1, it tunes its frequency onto the channel 1 and receives this signal. Now, suppose a jammer comes in and jams this particular signal. To overcome these type of situations or to provide a safeguard against these type of situations, frequency hopping scheme is implemented. Here what I do is, suppose I develop an algorithm that the first signal I will send over channel 1, second signal also I will send over channel 1, third signal I will send over channel 2, fourth signal I will send over channel 5. Okay? You have 80 such channels, 79 channels. Okay? So now the receiver is also aware that the first signal will come over channel 1, second signal will come over channel 1, third will come over channel 2, and fourth will come over channel 1. So randomly the receiver will tune or hop its frequency channel in accordance with the pattern in which the transmitter is going to send the signal. This is how jamming or error possibilities or due to interference they can be reduced. Have you got it now?
Yes, sir.
And this is frequency hopping. And
Okay.
direct spread DSSS is basically the case where I increase the length of my signal. Suppose this is my signal. I convert this signal into that much length and then send it to the receiver, which knows what the request means. It decodes. And the other is, which is very popular these days, you want to know CDMA. I think we are over, we have passed our scheduled time. So it is okay.
Yes, sir.
We are also looking for CDMA, which is very interesting.
Sir, last question.
Yes.
In case of traffic modes,
Yes.
what is the simple meaning of beacon?
Beacon
B-E-E.
basically it's an alarm. Jal jao sab.
Okay. Okay, sir. Thank you for discussion.
Okay. So thank you very much. The next session is due to start and at 11:30 after the tea, and hope to meet you.